Hi, good morning, everybody. It's a wonderful Sunday. This is me, Yong. My team members, Kanwei, Vikin, Hing, Leong, and He. We are the people who like to do online shopping. And we make a perfect team to solve the e-commerce Clickstream big data problem. Let's look at Clickstream. What is Clickstream? Every time we visited an e-commerce website, things that we search, things that we click, we check out and enter the credit card numbers, they're all being recorded. The purpose of this is because the e-commerce website would like to give us a best shopping experience. They call this a customer-centric analysis. Right? Do you know that 35% of Amazon sales are contributed from their recommendation systems? That's exactly what Clickstream data can provide. Customized, tailor-made shopping experience that hook you up to come back again. And to solve this problem, this is a big data problem because doing this requires a lot of data. 6 billion write and 5 billion read at the daily basis reported for eBay. 50 terabyte of data have been processed by the data analyst. A total of 700 concurrent access to the data in order to do this analysis and provide us the customer-centric analytics. So this is definitely a big data problem, and we could look at how to solve it. At first glance, it looks like a straightforward problems where we just need to intake all the Clickstream data, put it into the real-time database, and have a means to transfer the data to a warehouse and then for analytics for machine learning purposes. So it looks that simple. We should also consider that there are other systems in the entire IT infrastructure, right? Other than the Clickstreams, there are many other systems, there are many other applications, many databases, there are even security monitoring require all kinds of data from the web service, right? Not just the Clickstream. So when we design the big data infrastructure, we have to consider all this in mind, right? Now, so what we did is we set up a reference architecture for our exploration. So what we have here is we introduce a middleware called the message bus, where all the data should be sent, regardless of a Clickstream or any other type of applications data, it is sent to the central bus, and we let the central bus distribute the data to the respective system. Okay, the things that we are interested in, of course, today is just a Clickstream, right? And we will also explore what the tools that we should use for extracting ETL process and what are the best candidates for warehousing and also analytics. Okay, so we look at this is a popular chart. Here we are going to look at we're going to explore all the green colors, tick boxes. Yes, of course, on top of Hadoop and HDFS and MapReduce, we look at Kafka as the middleware, Hive as a warehouse, as a ETL, Pig, we explore using ETL process, Huishbase for the real-time database, and it also comes with the utility to do some data extraction. Spark also we explore as an ETL tool. So let's see what's our recommendation. And before that, we set up a lab. This lab is basically one PC with 16 GB RAMs, and we have multiple. We set up a cluster of 3 virtual machines, a name node and 2 data nodes, just to make the things more realistic with actual Hadoop cluster. And we have 2 edge nodes. Edge node 1, we install the HBase, Hive, Pig, Spark, and Zookeeper. And edge node 2, we will concentrate on the Kafka systems. Right. So on the PCs, we also installed Tableau and Power BI just to demonstrate that we are able to pick up the data for analysis, right, at the end of the day. Right, so this is, based on our various testing, this is what we recommend. Firstly, the web servers, this is what I recommend, this is also what we simulated in the lab. Firstly, the data, we use a data generator program to constantly generate click data streams into Kafka systems. And through the Kafka connectors, HBase sync, we managed to ingest the data into the HBase database, and we eventually recommend or choose to use Pig as ETL tool and pick up the data from HBase, and we can do transformation. We clean up the data because Pig is a programmatic, programmable utility. So we clean the data, we transform the data to the format and the structure that we wanted. We store into a CSV file in the directory in HDFS. Okay, and we've chosen Hive as a warehousing solutions. Hive, one of the reasons because Hive supports Thrift server, so we can use that to connect to external BI tools through ODBC. So Hive will retrieve the data from the same CSV folder, and through MapReduce, or sometimes directly without the MapReduce, it will handle the query from the ODBC. Okay, so all this is done well. This is all working already. Right. So moving forward, what we think can be improved from the previous lab setup or previous system is to introduce clustering. We think in order for the system to go live or even production, definitely we need to test a clustering approach to the entire solution, right? So we should apply clustering to Zookeeper, Zookeeper to Kafka, HBase, Spark, even Spark supports Zookeeper. And I just realized Hive also supports Zookeeper, so we can have a high availability for the 700 concurrent data analysts. Okay, so we should also explore machine learning. Through Spark, we can export the data out for machine learning program out there. And other interesting things, real-time analysis by Kafka real-time streaming analysis is a new component we can export as well. And the new lab should look like this. The new lab should have redundant name nodes, multiple data nodes as if we need it, we need to scale, and clustering of the various components as we discussed earlier, right? So when we need to scale, we just need to scale the H node and the data node. And the conclusion, right? Conclusion, big data problem for Clickstream is real and it's really big. And the solution for the big data is a wild world, right? We need to use what works best for that problem, and also we need to choose what works best for you, right? So we have to balance what are the best tools and what are the best tools that you know how to use, right? And keep in mind what works today may not work tomorrow. Okay, for example, I just noticed that Hive version tools, they already duplicated MapReduce and they move on to Spark. So maybe Hive can no longer be used in the new version, right? Whatever it is, as the big data implementer, we need to definitely know some Java, right? To a certain extent, you need to recompile the Java codes because what is out there is not always the latest. The latest, you have to search it from GitHub and you have to compile yourself, all right? So thank you for your time. I hope you have a nice day.